it's me, S. Rasmussen, and today it's my second science video, a video about hydrogen-induced cracking, or HIC. And this is, again, a video for me to practice before my exam, so that's fun. So this is a thing when hydrogen sulfide is close to steel, and what happens is that it splits off hydrogen ions. So at last stage you have sulfide ions and two hydrogen ions, and the sulfide ions, they hinders the two hydrogen ions to combine into a hydrogen molecule. And the hydrogen ions are very small, so they diffuse very easily and quite rapidly as well. And they have a tendency to collect in cavities within the steel, and as there is no hydrogen sulfide or sulfide ions for that matter inside these cavities, these hydrogen ions can then combine into hydrogen molecules. And the problem with this is that after a while the pressure will increase. For the gas has nowhere to go, and for the basic thermodynamic rules, the pressure will then increase. And this is especially critical if the cavities have unwanted shapes, like being quite long and narrow, maybe a bit pointed. If that happens, it can take less pressure than others, and it will crack up to the surface for a pressure release. So this can be quite damaging and could be hard to predict. So, but how do you avoid this? Well, the most obvious solution is to not have hydrogen sulfide nearby at all. Another solution is to have the cavities be very spherical or ball-shaped. Then it can take more pressure, so not cold rolling the steel if it's gonna be used in hydrogen sulfide environments. So yeah, not having hydrogen sulfide close by is an obvious solution, of course. Another solution is to place a oil layer or other corrosion hindering thing on top. Thus, not so much hydrogen will diffuse into the steel, and the sulfide becomes, in a way, harmless. Or not harmless, but it's never harmless, but it won't diffuse as easily. Another thing one can do is add a little bit of copper into the steel, and another thing one can do is dehydrate the surroundings so there is no water.